Hey, Troy here with Lithogen. It's kind of a slow, rainy day and there's not much moving in the shop today. So Bertrand and I are going to film another training video. If you saw our EM38 video, it was quite long. Today we're going to deal with the EM31, the spiritual brother of the EM38. It's basically a larger EM38. The problem is that our lot is full of fences and cars and things like that, so we're not actually going to get very good data today with the EM31, but we'll show you how it works, how you calibrate it, how you test it, how to get good data with it, and how to do some basic processing. So this EM38 here was packed by us as though it is going to a customer. So this is what you would receive if you were renting an EM31 from us. I think I said EM38 a moment ago. Comes in a fairly large box with 4 clamps on it. And I always take the lid off, and if you're doing this outside in the field, like if you're in the grass or something like that, I use the lid kind of as a work table to spread everything out. So there's a bag of stuff in here. So I'm going to go through the components here and kind of show you what all the different parts of this instrument are. For starters, when you unpack it, the first thing you notice is that there's a shoulder strap. Depending on the age of the instrument, it might be leather or cloth of various types. This one is leather because this instrument is actually a bit of an antique. This instrument was made probably in the late 90s, but the design hasn't changed at all. I think 1996. Actually, one thing that's interesting about this instrument is because it's an older instrument, it's been continuously upgraded over its lifespan. I'm going to do that again. There's a lid on the top of the instrument. This blue lid here. Clamps open. There's a hinge at the back. If you knock the lid sideways, you can pop the pins out of the hinge. And to put it back in, you just line it back in, up, and slide it back in. For shipping and stuff. Some people like to survey with the lid on. Some people like to remove the lid when they're surveying. If you survey with the lid on, you're not going to bump the dials by accident, but it adds a little bit extra weight and a little bit extra noise because everything's making noise while it's moving. So that's your option. I'm going to remove it here because it makes for easier filming. First thing you'll notice about this particular instrument is that there are some older features in it. One is there's this tray here in the middle that isn't present in the modern EM31s. And I'll just grab off the shelf what actually goes in that tray. This is what the data loggers used to look like when this instrument was originally designed, and it would fit in here. But it doesn't exist anymore, so it's kind of a vestigial tray. What we've done to this instrument, even though it was built in 1996, is we've upgraded it with Bluetooth, and now it communicates with the data logger, which is in its own tray via Bluetooth. So there's no cables actually connecting the data logger, the GPS, and the instrument. They're all operating independently. I'm actually going to go through the setup of the instrument here first. And we'll just put the lid back on for a moment. The lid has these nice rubber bumpers on the top, and that allows you to flip the instrument over more easily so it's not sitting on the dials. So I usually leave the lid on when the instrument is unturned. On the bottom there's a large thumb screw, or like a hand screw. And if you unscrew it all the way, you can remove the two booms that are shipped in the instrument. I usually just put them in the box temporarily and then screw the bottom tray back on. The reason you want to put the bottom tray back on is this bolt right here. If you don't have this tray on, all of the weight of the instrument is going to sit on this bolt. It's actually about 3 hours of labor to replace this bolt if this bolt breaks. So we want to protect it, this tray, once it's screwed back on. Now it forms a nice bottom surface that the instrument can sit on. So if you need to put it down, it's not sitting on that bolt. I'm going to flip it back over. And I'm just going to get the shoulder strap out of the way temporarily. And take the lid back off. The two boom arms that we took off a moment ago have a color-coded sticker on them. It matches red to red, and it'll say transmitter and transmitter. There is a male and female connector, so you can see pins here and slots here. If you have a newer version, these are going to be a different set of pins, but the effect is the same. They just replaced this particular connector sometime about 10 years ago. There's a pin here, so you can only install it in one direction, and it's the only correct way it'll slot in. Once it's slotted in, clamp down to tighten. If the clamp isn't tight, adjust the screw, and then clamp down. That sounded tight. That sounded tight. It's obviously a lot easier to do in a warehouse setting, but most of you will be doing this on like a tailgate of a truck or on the grass, depending on where your survey site is. Like the transmitter, there's a green dot here on this side, and because this one's an old ancient one, it's actually missing the green dot here, but it says receiver on both of them. And again, there's a male and female, you can only get it correct in one direction. Tighter. Go. Okay. The last thing to fully assemble it is there's a hip pad which is Velcro on it. Sometimes these Velcro straps will come off or whatever. Occasionally people have had to tape it on, but usually you just stick it on here, and assuming that your hip is sitting right here while you're carrying, then it will kind of just cushion the bruise that you would otherwise form. There's a couple other pieces here I'm going to go over quickly. One is there is a battery tray. On most of our EM31s, there is a thumb screw here. This one's older, so it actually has a push lock screw with a flathead screwdriver. You can usually give it a quarter turn to unlock it. The battery tray is very low tech. Looks like this. There's 8 batteries in there. When you're inserting or removing batteries, these metal tabs can actually cut your hands if you're not careful. Usually I recommend using gloves to take the batteries in and out, or at least if you have a flathead screwdriver, you can do something like put it underneath and then give it a twist and it will just pop the battery out. Right? You don't want to damage the battery or the circuit board underneath, you just want to be gentle with it. There's a plastic cap on the positive side of the battery, and just a conductor on the other side. Popping them in, you want to be making sure that these tabs are making contact with both sides. If they're not making contact, sometimes you have to go in here with your fingers and kind of bend them in a little bit.
This is actually one of the most common problems, is you don't have good power from the battery because it's not making contact on these tabs. So there we go. We tested these batteries prior. They're good enough for a training video. They're not brand new. Typically a set of batteries will last you half a day to a full day, depending on the temperature. Just gonna lock that screw in, so now the battery tray is locked in. A couple of accessories that come with the device. We usually ship them in a plastic bag or a pouch or something like that, depending on the instrument. There'll be a copy of the manual in there. Usually one spare set of batteries. We usually presume that our customers are going to provide their own batteries, but sometimes when you arrive in the field on the first day and you're like, oh, the batteries are dead, we need a spare set today in order to keep running. So we always put one in there just as a courtesy. There's a bunch of cables in here, and I'll go through them quickly. You won't use most of them. In the old days, before Bluetooth, you would use a data logging cable that went from this port. If you didn't have this data logger here, you would put this data logging cable in, and then it would go to a serial connection, which you could then plug into your data logger. And then data loggers stopped having serial ports, so then they started shipping a USB adapter so that you could go to your data logger with a USB port. But now everything's with Bluetooth, so these are still here just kind of as a vestigial thing. In case for some reason the Bluetooth isn't working, or you have to switch to a data logger that doesn't have Bluetooth or something like that, that's the only reason they're in the bag. You don't need to use these regularly. Finally, there is 2 charging bricks in the bag. One is for the Mesa data logger. It just has a charging port on the bottom. And the other is for the GPS. Usually we ship a geode GPS with this. As a 30 centimeter accuracy, it's more than enough for an EM31 survey. The data logger has a built-in GPS. It's about 4 meters accuracy, and depending on what you're surveying, that might actually be enough, and then this becomes optional. Actually, I'm going to take the manual with us. On the front page of the manual, I always leave a note. It says, see page 12 for pre-job checkouts. It's actually really super important, and some of our clients occasionally miss this, and they'll get to site and they'll wonder why their data is off by some percentage, and that's because they didn't do the pre-job checkouts. This is basically like an on-site calibration process that should be done on every site. Okay, a little bit about the data logger and the GPS here. It's just a thumb screw at the bottom of the GPS. This is a standard 1/4-inch bolt that goes onto the bottom of the GPS. Just feed it through. If for some reason you lose this screw, it's not the end of the world. It comes from Amazon. It's like $1.20 or something like that. You can use any 1/4-inch bolt in a pinch if you are in an emergency. Speaking of 1/4-inch bolts, I think this is one here too. Some of our devices have like a linch pin or a pull pin here that like allows you to release this so you can slide the Mesa in and out. In this one here, we've replaced that with just a 1/4-inch bolt that is just thumb screwable in the field. I'm gonna pull out the Mesa just so it's easier to film. I don't know how the reflections are gonna look like, so we might have to adjust this. Okay, what we're gonna do is we're gonna turn the EM31 on. Right now it's in off mode. We're gonna turn it to operate, which is the second tab. We're also gonna turn the GPS on. I'm just gonna spin it here so it faces the camera and we can see the lights. It's a 1 push button operation. And we're gonna turn the tablet on. I fully shut the tablet down because I wanted to save battery. If you put it to sleep instead of shutting it down, it'll boot up faster. There is usually a pen that comes with it that makes it a little bit easier to use, especially in the winter when you have gloves on and you don't want to use a touchscreen. But in summer, I'm just going to use my fingers. All right. The normal EM31 logging app is called EM31Win. Some of our systems also have Nav31. We're not going to talk about Nav31 today. We're just going to talk about the default one, EM31Win. And it looks kind of like this. But before you start surveying, we should ship it entirely pre-configured for you, so it should be ready to go. You should be able to see COM6 and COM12 here. And this is the GPS port and the EM31 port over Bluetooth. That number is going to vary depending on which instrument you get. And here's how you would figure it out if you didn't have... Sometimes there's a Bluetooth icon here. You can long press on it, but usually you hit the start menu. And then you hit the P3 button to pop up the keyboard. And start typing Bluetooth. And you'll see Bluetooth and other device settings. And here you can see which devices are currently paired. I'm actually going to remove this so that we can watch what the pairing process looks like for both the EM31 and the Geode. Okay, so if you didn't have them pre-paired, you would hit Add Bluetooth Devices, choose Bluetooth. It's going to search. Let's add the Geode first. Sometimes the Geode will ask for a password. If it does, it's 0000. And the EM31 is going to ask for a password, and it's going to be a very secure 1, 2, 3, 4. Now we want to check under more Bluetooth options, and at the tab at the top here it says COM ports. And we want to pay attention to what the outgoing COM port number is. So its outgoing is COM6 on the Geode and COM11 on the EM31. So 6 on the Geode, 11 on the EM31. Then you would go to your logging software and you go System Setup. And you make sure that it's matching what the system said. Now we could check if our GPS signal is coming in by clicking GPS monitoring. It's kind of hard to see, but a blue light came on right here for Bluetooth as soon as you hit that. We're inside the building, so we're not getting any satellites yet, and we just turned it on. We will get satellites in here eventually. It just takes a couple minutes. Right now, this is just the strings coming in from the GPS. If we hit logging, you can see GPS says no fix. If you saw this in the field, you would probably stop and try to resolve your GPS situation. The other thing it says is conductivity and in phase. These values are kind of nonsense because we're inside a building and we're surrounded by metal objects. Normally what you would do, and we'll do this once we're outside, is we'll go through our pre-job checkouts and we'll pay attention to what these numbers say here when we're following along with the manual. After the pre-job checkouts, you would hit Data File. And I usually make a folder in my Documents folder called Test when I'm making videos like this. So you would save it. And then you would hit Go. And this data logger is configured to beep at you. Not all of them are. I actually turn it off on some of them. But it reminds you that the instrument is actually working. The numbers here we're getting are nonsense, so I'm just going to turn this off. Oh, hey, look, we have satellites now. One thing else to note here is if you go into the logging window and you want to check your battery. You go over to the switch here. Right now it's set to 100 is the range. We're going to set it to battery, and then we're going to go back to the screen, and you can see it's reporting negative 5.6 volts on one of them and plus 5.6 volts on the other. Do not record data in battery mode. You will just record your battery levels all day. Make sure that switch is not set to battery. Okay. I think that's enough for now. We are going to gear up and head outside and splash around in the puddles a little bit and record a little bit of a montage about how we're actually going to collect the data. System's on, GPS is on. We're gonna hit logging so that we can access. It's gonna be hard to see the numbers here. There's some numbers here across the top. It recently rained here in Winnipeg, and so the conductivity number is about 130, which is expected, and the in phase is 5. Just to give a little bit of context, we are trying to be as far away from anything metal as possible while we're calibrating. It's not really calibrating, it's more like pre-job inspections. What we're doing is we're setting our zeros to a background value. If you're doing this out in the field, you would want to go find a spot that's far away from your survey area and do it there. The manual says, see page 12 for pre-job checkouts. And this is a thing that's skipped by a lot of people in the field. We want to go to page 12, and we want to start at the beginning. It says the range should be set to 100 millisiemens per meter. We're going to leave it at 100, even though that we're reporting 130. It says we're actually reading greater than 100 millisiemens per meter, but we're still in range. Really, this range dial is between 20 and 200. You want to be in this range, so we're in the right range. We're going to set the mode switch to Oper, which is operate, and then on the screen we want to set our phase to be 0. And right now the phase is plus 5.2. So there are 2 dials here that says fine and coarse. I'm going to unlock the fine one, and I'm going to switch the coarse one until I'm close to 0. So I switched it 1. Oh, that's actually really good. I switched it 1 notch here, and now my reading for phase is 0.0, which is pretty much close to perfect. But you might be able to adjust it slightly with the fine and coarse knobs. I'm going to lock the knobs back in place. So I just use this lock nut here to this is unlock, and this is lock. Once it's tight, now you can't rotate that by accident. Okay, so that's the first part. We set it to 0. Going back to the manual, check the phase of the instrument by setting the mode switch to the phase position. So the mode switch is over here, and the top one is phase. Then it says, note the conductivity reading. So right now we have 130.3. And we want to rotate the coarse knob 1 step clockwise. Basically, the conductivity reading shouldn't have changed when I moved it, but now it says 132.7, which is more than a 0.2 difference. So, I'm just gonna use this as something to kneel on here because I have a gravel surface. What we need to do is we need to go back to operate, make sure we're on the right position. Go to phase. We're going to unlock the phase knob here. We're going to give it, just with my thumb, a quarter turn clockwise. Now I'm going to go back to the course knob and I'm going to click it and see if the conductivity changes. Yes, that made it worse. So I'm going to go back here and I'm going to rotate counterclockwise, counterclockwise, quarter turn. And I'm just going to repeat this process over and over again. So I think the tripod from the camera is actually affecting it. So we can't move this right now. Stay in exactly the same spot. So it's currently 130.0. I'm going to click it once. I get 131.2. I'm going to go another quarter turn. 129.0. Click it once. I get 129.1. We're actually really close. I'm going to give it like a tenth of a turn. 128.9. 128.9. Okay, I'm blocking the phase in place. Okay, you can move it now. We're going back here. And now our in phase is wrong. Before it was 0, now it's plus 20. So we're going to adjust this again. Okay, so we just finished adjusting the phase, and when you're done adjusting the phase, a click of the course should remain in the same spot. So it was 128.4. If I click, it's 128.3. Plus or minus 0.2 is enough. Rotate back. And then you have to change the dial back to operate mode and just verify that this didn't throw your phase off. So right now my in phase is reporting 0.14. I'm going to use the fine adjustment knob here just to tune that back to 0. The other way. There you go. It's a pretty touchy little knob. It's like a tenth of a turn is more than enough to set it off. And then tighten the lock screw back. Make sure lock screws are on both of them. Okay. Page 13. The next thing we're going to do is check the sensitivity of the instrument. To do this, we set the mode to the comp position, and you'll see the conductivity reported is close to 0. And then we rotate the course switch 1 click clockwise. And it should change the sensitivity on the instrument between 22 and 26 points. And we went from approximately 0 to approximately 24. If we pass this point, we have passed our conductivity checks. So that's fine. We're actually done here. Just getting ready for an actual field survey here. I'm behind the camera now with Bertrand with the equipment. And you'll notice that Bertrand is wearing rubber boots here that have CSA stamps on them and stuff. If you're gonna wear steel toes, they may potentially interfere with the instrument. So you can get fully composite boots if your health and safety requires you to wear them. Bertrand, I'll just give you instructions here. That way they can hear what's going on. So the first thing I'm gonna get you to do is you're in logging mode here. Everything's on. It's in operate.
Yeah, operate already.
And it's in the range of 100.
Yeah.
Okay. Now you're going to hit data file.
Data file.
And this is going to be hard to film. And
Okay,
you're just going to
file.
select the default file name.
Okay.
You hit save.
Save.
And then you're going to hit go.
Go.
And it's going to start beeping at you.
Okay.
Okay, so now you're going to do some zigzagging across the parking lot in about 5-meter paths. And I'll probably speed up the video when we show it on the internet. Okay. The data he's recording is going to be really crappy when he's right next to these metal fences and walls and but it's a good demo. We should see nice data in the middle of the parking lot. It should be far enough away. Probably this isn't very useful data because of all the rebar in the concrete, plus the metal fence. When you're next to the building, what is the conductivity reading? It's going crazy? And when you're in the middle of that lot, it's kind of stable? Yeah. Yeah. So, done. All right, we're all done outside. The instrument is surprisingly dry considering it was raining all day. Which is good because when you pack the instrument, you want to make sure the instrument is dry. If the instrument goes into the box wet, sometimes you'll get mold forming in the box, and sometimes it can cause long-term damage to electronics. You never really know where that bead of moisture is going to settle in the long term. It might settle exactly on a contact between two things on the circuit board or something like that. So try to make sure you pack it dry whenever possible. If you have to pack it wet at the end of your day, wherever you get to, your hotel, your camp, whatever, make sure you unpack it and let it dry. So the first thing we're going to talk about is just shutdown and data dumping. So you can turn off the GPS and the EM31 just by going to off, and then you can exit the data logging program. Just a thumb screw here on this one. Again, some of them have different clamps there. And hopefully Bertrand can film this okay.
Okay.
We have a USB stick, we're gonna plug it in. So USB has the magical property of being able to be backwards 3 times in a row. How's the glare? Is it okay?
Yeah.
That's better. Okay. So this is a USB stick here. You can just create a new folder in here, and then from the documents folder, we put it in the test folder. So we have all these files here. We're just gonna cut them. And we're gonna go back to our new folder and paste. So that's it for data dumping. You just use Windows Explorer. When you're done, pull the USB stick out. Some people prefer to use copy rather than paste so that they leave a copy on the device every night. Some people don't like to clutter the device. Okay, that's it for data dumping. We're going to talk about packing. So I'm going to go shut down just to preserve battery. Normally for packing, if possible, I will actually leave the Mesa and the GPS in their trays. But if you have to take them a different place to do charging, then you have to take them out of here. I'm going to leave them here. Put the lid back on. And then flip the whole thing over. That was the hip pad. Once it's upside down, unscrew this. It's a long screw. When you unclamp, depending on what surface you're working on, sometimes EM31 will want to do something like that, if you're on a tailgate or something. I usually just temporarily put the booms here until I have both of them. Okay. So on this boom, there is a skinny end and a fat end. Only the skinny end is going to fit into these clamps, so you have to make sure you position the boom appropriately. If you try to put the fat end in here, it's not going to close properly. So you have to put the skinny end. I usually then use my hand and just line it up flush on the one end. Do the same thing with the other boom. Just line it up flush. Once it's lined up, screw this back on. And assuming you went with the skinny end through here, it will actually look pretty decent once it's clapped on. Like it won't be having to play, it won't be on a weird angle or anything like that. Some people have trouble getting it back into the box, but if you lined up everything on one end, the easiest thing to do is put that end in the box first, put it all the way against the wall, and then on this end, where the clamps are, just kind of let the clamps ride down the wall here. And then it should be nice and snug, and it's not going to go anywhere. On some of them, this is detachable, and this one is not, so I just kind of set it to the side, hip pad. And then I usually try to close this just so things don't fall out of the bag. Okay, it's packed and ready to ship to the next customer.
Okay, hi guys, Andy with Lithogen. So in the previous video, Troy has walked you through how to copy the data from the EM31. So there was a whole bunch of files that he copied onto a USB, but actually only one of them is needed, and it has the R31 extension. So this is the only data file we will need for processing. We can open this in Notepad just to take a look. As you can see, there's a whole bunch of numbers. Something I can recognize is this one looks like a GPS string, and there's some numbers here that I have no idea what they means. But we're going to do some processing first and change this into a format that we can read. To do that, you will need the DAT31 software. If you're renting from us, this should be provided into a USB that will ship it to you. But for the purpose of this video, I'm just gonna assume you already have the software. Okay, so what we want to do is we want to go to Convert Files and convert Mesa/Archer EM31 files. And we're going to choose input file, which is the one, the R31 file that I talked about. And I'm going to choose the output location, which is going to be the same folder, and press convert. Okay, converting is finished. Now we can open the data and take a look at what the converted file look like. And here is the G31 file, which is the converted file. We can open with Notepad. Here you can see it's a lot more readable now. So this can roughly translate it to, at this exact time, at this location, we had 2 data points. And the first number, 43, I think is data point number 43 and 44. 204 is the conductivity, and 8.5 to 3, I believe, is the in-phase number. And of course, you have the timestamp for each data points. Okay, so now the next step is to change this to another format, which is more friendly for QGIS. That format is called the XYZ. And to do that, again, we will go into the DAT31W and go to GPS positioning and GPS position. You will choose the converted file, the G31 file, as your input, and I will name it the same name, but with the XYZ for the output. And then the output format, I will do generic. And then for the UTM systems, I want to choose some meters because we're in Canada. Although you can use fit if you want to. And then click on apply. And exit. Now we should have something a lot more friendly for QGIS to read. It looks like I actually put it into the wrong folder. I probably put it into attempt 2. Let me just copy this one and move it to our new folder. Okay, look at the file. Here the columns are a lot more simpler. We have easting, northing, your QV1, in phase 1, as well as your timestamp. Before I move on, there's actually one more thing I wanted to do, which is clean up the header a little bit. So I will delete this slash as well as the comma. This is just so that it shows up with a nice columns in the QGIS afterwards. And I'll put a space in here. Actually, I'll just delete the whole thing because time is pretty obvious to read. And then I just clicked Ctrl S to save, or you can click this button here. And we should be able to close this notepad. Okay, the next step is to not install, I already have installed, but to open the QGIS, I have the QGIS version 3.4. So make sure when you do on your computer, you have something with a newer version. And I will move it to the screen. Oops. There we go. And I'm going to create a new project. And let's just save it before I forget. Call this EM31 tutorial. And press on save. And it's saved. To better grade this data, we're actually going to use a plugin called the ArcGeek Calculator. To install that, you can click on Manage and Install Plugins, and you can go to All, and then just search ArcGeek in the search bar, and click on that, and you should be able to install the plugin. Since I already have it installed, so I don't have exactly the option, but it should be this button here. Another tool we should have is called the XYZ tiles. So this is essentially a photo satellite of the Earth. What I use is this link, and I will put that into the description. So this is essentially Google satellite with no labels. And I can double click just to get the image started. Okay, so the next step is to add the XYZ layer that we just created or dumped from the EM31mk2 software. To do that, we can go we will go to Layer and Add Layer and choose Add Delimited Text Layer. And you should have something like this. I will make it a little smaller. Okay, so at the top file name, you want to choose the XY file that we just downloaded or we just converted, and it's this XYZ file. And here you can just pretty much copy all my settings if you did what I showed you before. And here is a finished product, what it's supposed to look like. We have 5 columns, east, north, QV1, IV1, and field 5, and you can see it's already detected that the field 5 is time. So I will just click on Add, and it might give you this window because it's asking you if you want to do the transformation or convert the coordinate systems. I will just say OK and close. Now I should have a layer. Added onto my layers menu, and I can just right click on that and choose zoom to layers, and this will bring us to where the area of your data collection, hopefully. Actually, just going back to importing a layer, I probably missed an important detail, which is the geometry definition. So I'll just put that file up again. So you want to make sure that your X field is your east and Y field is your north. Or if you dump it in not the UTM but the other coordinate formats, you can probably choose longitude and latitude respectively. And you want to choose the right geometry or coordinate systems. Because we did this survey in Winnipeg, so this is set to UTM zone 14. And that's why when I clicked on the ad and the data showed up in the correct location. If for any chance that your data showed up in the middle of the map, it's probably, in the middle of the Earth, it probably means that you used a different coordinate system. You just need to correct that. Okay, once we have the data layer added, we can go ahead, grade data. We can do that by go to plugins, ArcGeek Calculator, and then Kriging Analysis. And you should have this menu here. So the input point layer is going to be the layer that we just imported. The value to grid is going to be the quadrature. And output size, I'm going to do 0.5. So this is essentially what is the smallest pixel you want your data to be. So I choose 0.5, which is about half a meter. And for variogram model, it doesn't really matter unless you know what you're doing. Otherwise, you can just leave this as a default. I will just use linear here. Kriging type, blah, 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 all to default. And I'm going to name my output layer into this same folder, and I will call it, actually, what's the name for it? 0818138, and I will say 0.5 meter. And click on run. Okay, so after the process finish, you should have a layer put it on your map already. And I'm going to move this layer down below the path so you can see exactly where my data is. Okay, so the data are here. However, there are still two things I don't particularly like about this this visual. And for one is that the color is only in black and white, which I might want a better color ramp for displaying the variations in the ground. And then number two is I have this whole area where I have no data point, and the computer think that this area it's white. But what I really want to do is actually remove all this area where there are no data points. Okay, so let's do the color first. I will click on the layer, on the grading layer, choose property, and go to symbology, and under the render type, you can choose a single pseudo color. That's what I normally go. And for the color ramp, I choose this one here. However, you can choose whatever you like for your displaying purposes. And another thing I like is I like to get rid of the top 2% of the value, just so that the outliers are clipped out. And I will choose apply and press OK. So now the color is a little bit better in my opinion. Okay, now I will try to remove where I have no data, and that is because the interpolation methods estimate values between measured observation. But as the distance from the actual data points, for example here, increases, the the resulting value become increasingly dependent on the interpolation models. So essentially, those data points are not accurate. They're just computer guessing what your data might look like. So I want to remove that. So to do that, I will first need to create a layer where I'm telling the computer, okay, the data in this area are actually good. So to do that, I will click on Vector, go to Geometry Processing Tools, and click on Buffer. For the input layer, I will choose the points. And distance, this is essentially you're telling the computer how many meters outwards from the point you're collecting data you want to keep. So I will do 3 meters for the EM31. And another important thing is you want to choose the dissolved result. You can also save this layer, otherwise it's going to create a temporary layer and you might lose this layer later. But I'm just going to run it as a temporary, and I will click on Run. And here, as you can see, it now does exactly that. It extends the data outwards for 3 meters, and this layer is what we're going to use to extract the background. Okay, so now we go to Raster, Extraction, and Clip Raster by Mask Layer. So the input layer is our graded data. Mask layer is the buffered area we just created. CRS, I will just leave them as default. And it's very important that you unclick this, match the extent of the clip raster to the extent of the mask layer. You want to make sure you unclick this. And again, for the clip, I will save this as this might be my final result. I will just name this clipped.tiff file, and I will click on Run. And now I just need to hide other layers. And again, I will change the color of this to pseudo color to the 2% again. And voila. Okay, so the very last step is now how do we get this plot out of the QGIS software? And say if you want to load this into Google Earth, how do I do that? So the answer is we will want to export this into a TIFF file. And to do that, I will click on my final data and go to Export and Save As. Okay, on this window, you want to choose the 3-dot button, and this will ask you where you want your data to be, or your final image to be. And I will put it here, and I will give it a name. Let's just call it final. Choose save. And for the output mode, you want to choose the rendered image. This essentially accounts all the colors and the rendering into it. Otherwise, you might get a black and white photos. And then for the CRS, you want to choose this exact one, which is the EPSG3857. If you can't find it in the drop-down menu, you can click on this button on the right, and in the search bar, just type in 3857, and you can just double-click on this. And everything seems to be all right, and I will choose OK. Now I should have this image saved in my folder. Okay, so open the folder, and I should have my final data here. And now what I can do is I can open Google Earth. make it smaller. And I should be able to just drag and drop and click on OK. And your data will be here on Google Earth. And obviously you can choose your transparency so you can see your surrounding a little bit more. And this is how you process EM31 data. Andy from Lithogen, out.